In this video, we'll talk about the basic language constructs in C#. Both Java and C# are the so-called imperative programming languages. With an imperative language, we write commands or instructions that the computers follow. In other words, we tell computers what to do, and they do exactly that. The vast majority of programming languages are imperative languages. But there are also some other types of languages, like functional languages and logical languages. All imperative languages are similar to each other in the sense that they have the same language constructs. So whenever I try to learn a new language, I just go through this list, from the simplest to the most complex. The simplest, of course, is comments, then data types. From data types, we have variables and literals. Literals meaning the values of a certain data type. For example, 10 would be an integer literal, and ABC would be a string literal. And then we have operators, like add, subtract, multiply, and divide. And then we can combine variables, literals, and operators into expressions. An expression, by the way, is something that evaluates to a single value. For example, A plus B minus C divided by D times 200, for example. This may look like something complex, but eventually it evaluates to a single value, so it is an expression. And then from expression we have statements, like if-else statements, for loop, while loop statement, and so on. And then we can put some reusable code into functions and methods. Functions can exist on their own, while methods are basically functions attached to classes and objects. And then, if the language is a so-called object-oriented language, we'll have classes and objects, which combine data and operations together. And then, many languages also provide another level of encapsulation, like package in Java and namespace in C#. In this video, we'll cover from comments to statements in C# and leave the more complex constructs for later. As we'll see, most of the basic constructs are similar or identical to their counterparts in Java. So, comments. Just like in Java, we have single-line comments starting with double slash and block comments with /* and */. So very quickly, for example, this would be a comment, and this would be another comment. In Java, we can use a special type of comments, /*, and then //. And the Java doc tool will create documentation based on these special comments. In C#, we have pretty much the same thing, except that instead of double star, C# uses //. Now, data types. Data type is where C# and Java differ quite a bit. First of all, C# uses .NET data types. These data types are defined in the system namespace. For example, the 4-byte integers is the type for 4-byte integers is system.int32. When your code imports the system namespace, as we're doing here, we can simply use int 32 to declare a variable. What gets a bit confusing is that in addition to the system types or the .NET types, each .NET language often has their own type keywords that are mapped to .NET types. For example, C# has the int keyword, which is an alias to the int32.NET type. So that means you can also use int to declare an integer variable. Here's a list of common data types in C#. The first column is the C# type keywords, and the second column is the equivalent in system types, aka .NET types. The full list is in table 3-4 in the Pro C# 9 book, and I also made it available online, linked from the slides. You can tell by looking at the type keywords that if it's a C# type, it's all lowercase, but if it's a .NET type, it starts with a capital case. As I said, the C# type keywords are just aliases for the system types. Functionally, they are the same, so you can use either one. The Pro C# 9 book uses C# type keywords, int, for example, instead of int32. And this is also my preference. So in this class, when I do examples, I'll stick with C# type keywords. Although if you prefer, you can also use the .NET types. Now let's talk about some differences between Java types and C# types. The first difference is that in Java, types like integer and int are two different types. For example, in Java, you can do integer.parseInt, but you cannot do int.parseInt. In C#, int and int32 are the same thing, so you can do both int32.parse a string and also int.parse a string. This difference actually goes beyond just names. Fundamentally, Java has two types of types, or two categories of types. One is the primitive types like int, double, and so on. And one class types. For example, you would have integer and double, and so on. In C#, on the other hand, all types are class types, which is why we can do integer 32 parse or int parse, because parse is really just a static method in the int class, and int, as I said, being also a class type instead of a primitive type like in Java. Now, with that being said, not all class types in C# are the same. Some of them are called value types, and some are called reference types. You can see the list of them in figure 3-2 of the Pro C# 9 book. Again, I have made the figure available online here. For example, you can see that Boolean, byte, char, in various integer types and double and so on, these are all value types. On the other hand, object types string, array, exception, these are all reference types. So you may be wondering, what's the difference between value types and the reference types? The short answer is that value types behave like Java primitive types, and reference types behave like Java class types. So what does that really mean? Let's see these two examples. On the left, we have an integer int variable a. Suppose we assign a to another variable b. We then change the value of variable b from 10 to 20. Now, does the value of a change? The answer is no. A would still be 10. The reason is when we assign a to b, the system copies the value of a to b. So b is a different copy from a, and changing b does not affect a. How about the code on the right? This time, a is an object, and assigning a to b makes b pointing to the same object. And this time, changing the value of the object through b will also change the value of the a variable. So now a dot value would also be 20. And this is the behavior of reference types, while this is the behavior of the value types. And again, these behaviors are the same as in Java with primitive types and class types. Whether something is of value type or reference type also affect how it's used as an argument to a function or a method. This is known as pass by value or pass by reference. The idea is the same as before. If you pass a value type variable to a function, changes to the argument inside the function will not affect the variable outside the function because these are two different copies. In this example, for example, after we pass a to the change function, and inside the change function, it changes the argument of a, but once the function call is done, outside this function call, a would still be 10. It won't be changed to 20 because what happens inside the function happens to a copy of a. However, for a variable of a reference type, changing the object inside the function will affect the variable outside the function. So this case, again, a dot value will change to 20 after calling the change function. And this is passed by reference, and this is passed by value. So C# has a number of predefined value types, as we see here. And there's also a way to define your own value type, known as an enum type or enumeration type. Suppose you want to limit a variable to only a few possible values. You can create an enum type. Like in this example, we define an enum type color with 3 possible values, red, green, and blue. Internally, these values are actually represented by integers starting from 0 by default. You can change the default integer values when you create the enum type, like this. And if you want to change the default values for all of them, just assign an integer value to each of them. And then in code, you can use color.red, color.green, color.blue as values. And if you want to get their text names, simply do a toString. In Java, a primitive type variable always has a value. It's the same behavior in C#. For example, if we declare a variable int a, then a would have the value 0, even though we didn't assign it anything. This is different from reference types. For example, if we declare a string variable b, then b would not have any default value. Instead, b would be just null. In Java, there's no way to make a primitive type variable null. But in C#, we can actually do that by using a nullable value type. For example, if we want to have an integer that can also be null, then we can simply declare the variable as int question mark. So to create a nullable value type, we simply attach question mark to the original type name. And this time, this variable can be any integer plus it can also be null. For example, here, if we try to assign null to a, this will be an error. However, if we make a nullable int, and now that error is gone. This feature is quite useful when we deal with relational databases where a field can always be null. The one catch you need to be aware is that a value type and its nullable type are considered two different types by the compiler, so you cannot do assignment between them without a cast. For example, let's say we have an integer a is 10 and a nullable integer b, which is 20. If we want to assign b to a, you may think it shouldn't be any problem, but there is actually an error here because the compiler considered b to be a different type from a. So in order to make this assignment happen, we have to do a cast. By the way, the syntax of casting a variable is the same as in Java. We just do a parenthesis and put the type inside, and this will do a forcible conversion from a value of this type to a value of this type. In C#, we don't always have to explicitly declare the type of a variable. Oftentimes, we can simply declare them using the keyword var, as long as the compiler can infer the type of the variable. For example, here we assign 10 to this variable a, so the compiler can infer that a should be of int type. Similarly, the compiler can infer that b should be a double and c should be a boolean. And it will look something like this. If we say var a is true, the compiler will infer a to be a boolean type. And if we mouse over it, you can actually see the inferred type, which is bool. Note that once the type of a variable is inferred, it cannot be changed. For example, we cannot try to assign an integer to a because a is already determined by the compiler to be a Boolean variable. And this is different from JavaScript, if you are familiar with JavaScript, which also has the var keyword. But in JavaScript, a variable can change to any type at any time. You might be wondering what's the purpose of var for a strong typed language like C#? Is this really just to avoid typing long type names like double? Well, yes, there is that, but it also has a much more important usage later when we deal with dynamically created classes. Dynamically created classes are classes created by the compiler, and because they are created by the compiler, we don't even know the class names, so we cannot declare a variable using the class name. In those cases, we actually have to use var to declare those variables. And as in many languages, in addition to variables, we can also define constants whose values cannot be changed. In Java, the keyword is final, and in C# is const, stands for constant, of course. Now that we know the types, let's look at the literals. Again, they are mostly the same as in Java. We have true and false for Boolean, we have integers, we have floating points, numbers, we have single quotes for character type, and we have double quotes for strings, and we have the special value null. I highlighted a couple of things that are different from Java. First, in C#, we can use underscore as a separator to separate digits in a number. This is kind of like English. In English, for example, we would write 10,000 as 10, comma, then 30. And this makes it easy to read. In C#, it's the same thing except it's underscore instead of comma because comma is used for something else. C# also has a keyword default that represents the default value of a value type. For example, we can do a int a equals default. This assigns the default value of int to this variable a, and in this case it's basically 0 because the default value of an int variable is 0. There are a couple of things related to string literals. First is interpolated string, also known as template string or string interpolation. This is useful when we want to create a new string based on some existing variables, like this one where we want to create a greeting message based on the variable name. In Java, it's kind of tedious to do this. You'll normally need to do a string concatenation, something like hello plus name plus exclamation mark, something like this. Or if you don't want to do this in Java, you have to use a string.format method, which is somewhat tedious to do. In C#, the code is a lot cleaner and readable with interpolated string. You can start the string with a $ symbol, then put the variable in braces inside the string, and that's it. In fact, what's in braces can be an expression. Recall that expression is anything that evaluates to a single value. So you can put any expression here, and if it evaluates to a value, then the runtime calls toString on it to produce a string, then combine it with the rest of the string. Another string literal related feature is the verbatim identifier. This time, instead of the dollar symbol, we use the @ symbol. This is mostly used in two situations. One is when you specify a path on disk. The backward slash is used as path separator on Windows, but it's also used as the escape character in Java and C#. So when you use it in a path, you have to use another backward slash to escape it, like this. An alternative is to use the verbatim identifier. And this identifier tells the compiler to treat backward slash verbatimly without any special meaning. Another alternative for specifying paths is simply using the forward slash as path separator. This actually works on all platforms, whether it's Windows or Linux or Mac OS. The second situation where you would want to use a verbatim identifier is when you want to create a multi-line string. For example, we can create a string that consists of multiple lines. For example, we can say HTML, and then we can say body, and we can close the body, and we can close HTML. And the whole thing will be considered one string, including the new lines inside a verbatim string. Okay, now we're done with variables and literals. Let's talk about operators. Again, they are mostly the same as Java ones, so no need to rehash what we already know. I highlighted the ones that are not in Java, or the ones that behave a bit differently from the ones in Java. First, C# has a nameOf operator that returns the string name of a variable or a type or a type number. For example, we could declare a variable, and if we do name of A, it will return the name of this variable as a string, so this will return a string A. Now, you may be wondering, what's the use of this? Well, normally you don't see this used much, but it becomes kind of useful later in web development, because in ASP.NET Core, the default routing is based on the names of the controller classes and methods. We'll see how the nameOf operator is used for that later. An important difference between Java and C# operators is that in C# we can actually use the equal operator and not equal operator to check string equality. Remember, in Java, we have to use the equals method if we want to check if two strings have the same value. In C#, we can do that by simply using the equal and not equal operator. In fact, in one of our examples, we actually did that here. We are using the equal operator to check the values of two strings. In Java, you would say something like color.toString.equals and then the red string, but here we can use the equal operator, and that's not a typo. Now, two things to remember though. First, this is a special case for reference types. String is a reference type, and normally you cannot use these two operators to check the value equality of two reference type variables, but for string it's a special case. For other reference types, you'll still need to use the equals method, just like in Java. Secondly, these operators do a simple character by character, case sensitive, culture insensitive comparison. If you want a more sophisticated string comparison, you'll need to do some extra work. For example, if you want to do a case insensitive comparison, you'll need to convert both strings to all upper or all lowercase. And a more complex comparison would require the use of equals method again. The equals method has options like whether to ignore case and whether to do the comparison under a certain value. I highly recommend that you take a look at the linked documentation, which is this one. It's not just to understand the meaning of this string comparison options, but also to kind of appreciate the complexity of string comparison when there are multiple languages involved. For example, the documentation gives an example of a German word that has two different spellings, and in German, those two strings would actually be considered equal, even though they spell differently. Since equal and not equal work for strings, you may think greater than, less than would also work for strings. But that unfortunately is not the case. For that, you'll have to use the compare method in the string class, like in these two examples. C# also has two null-related operators. The first is called the null coalescing operator. It's a double question mark. You can think of this one as a shorthand for the conditional operator when checking for null. Basically, it returns x if it's not null, otherwise it returns y, which is equivalent to this using a conditional operator. The null conditional operator, in my opinion, is more useful. Oftentimes we want to get the value of an object, member or an array element. But what if the object or the array is null? If we don't check if the object or the array is null first, we may get a null exception error. So normally we have to do something like this. We'll have to say, check if the object is null. If it's null, then return null. Otherwise, return the member of that object. Similarly, for array, we first check if the array is null. If it's null, we return null. Otherwise, we return the element in the array. And the null conditional operator makes the syntax a lot more concise. For example, all this becomes this one, and all this becomes this one. And this is especially convenient when we need to do this at multiple levels. Take this as an example. Suppose we have a person class, and the address of a person is also a class. Suppose we want to check if a person lives in LA. Normally, we need to write code like this. We first check if the person object is null. If it is null, return false. Otherwise, we then check if the person's address is null. If it's null, return false again. Otherwise, we check if this person's address, city is LA. So this is the code we would write in Java. With C# becomes a lot more concise. Using the null conditional operator, we can simply say person question mark address question mark dot ct equals to LA. And as you can see, this looks a lot better. Okay, so other than a few things, there's not too much difference between C# operators and Java ones. And in fact, there's even less difference when it comes to statements. The C# statements like if else, for, while, and so on are identical to Java ones, except for the for each loop and some additional capabilities on the switch statement. In Java, the for loop has two formats. The first format is the regular for loop, where you specify an initial condition and you specify a terminal condition. And you specify increment. So this is a first form of for loop in Java. And the second form of for loop in Java is also known as a for each loop. It will be something like for string s in colors, something like that. Now, in C#, it's basically the same thing, except C# separates these two forms into two for statements. The for loop is for the regular for loop as in Java, and the for each statement is for the for each loop as in Java. If you compare the Java syntax and the C# syntax, you can see that they are basically the same, except that they use different keywords, and in C# it uses in, and in Java it uses column, but otherwise they are really the same thing. And since now we know loop statements, let's quickly talk about arrays. Once again, C# arrays are mostly like Java ones. We declare, we allocate, and then we populate the arrays. Or we can do it all in one statement, and this code is identical in both C# and in Java. C# does have an additional array syntax, also often called array literal. This allows us to create an array dynamically by specifying all the array elements values instead of using a for loop to populate the array elements one by one. And one more difference between C# and Java arrays. In Java, all multi-dimensional arrays are so-called array of arrays. Basically like this. For example, if you have a two-dimensional array, you use two brackets to declare it, and then you use two brackets to access an element in it. C# has the same syntax, but also additional syntax for matrix-like multi-dimensional arrays, where the rows or columns have the same number of values. For this type of arrays, the syntax is just one bracket and with commas separating the dimensions. Okay, so this is a quick introduction to the basic language constructs in Java. By and large, they are quite similar to this. Sorry, let me say that again. This is a quick introduction to the basic language constructs in C#, and by and large, they are quite similar or mostly the same to Java. Please read chapter 3 and 4 of the Pro C# 9 book, and thank you and see you in the next video.